I love making a list. Who's a list maker here? All of us, of course. But who's had a shopping list given to them by somebody else and bought the wrong thing? Again, all of us. Shopping lists are go-get commands. You look at the list and it tells you what to go and get. We run into some trouble when we almost get the right thing. You put a tin of baked beans on the list, and I come home with the wrong brand. Disaster. Approximations, particularly when it comes to beans, won't do. The most likely brand of beans might not be, or might be, the perfect beans. Often they're not the perfect beans. I'm Simon Grennan, cartoonist, list ponderer, and Professor of Art and Design at the University of Chester, UK. When we use an online search engine, we're giving it a shopping list and asking it to go get. It can choose from the whole of the World Wide Web and beyond, instantaneously. But search engines can be bad shoppers if we don't specify what we want. The search engine presents us with the most likely outcomes according to the patterns of commands we use and records of past list making. It will even come up with options ranked from most likely to least likely, how useful we think. But imagine taking home all those different tins of beans, most of which are only approximations of the right beans. There's lots of brands of beans out there. And remember, an approximation of the right tin of beans is not exactly the right tin of beans. Very recently, machines have been invented that don't simply search and present most likely items that are available in the vast digital world. Instead, they use most likely lists to generate new combinations of data. These machines can make new combinations in every medium. It's shocking. It's almost like magic. From mathematical formulae to movies, audio to writing. These machines are known collectively as generative artificial intelligence or generative AI systems. Generative AI can seemingly astonishingly write a poem, or a PhD thesis, might be a little helpful here. Provide an answer to a verbal question, speak with the sound of someone's voice, offer legal advice, create a new visual image from a language command. It can do this for two very simple reasons. First, the amount of data, digital data, available to search is technically known as large. In fact, vast might be a more descriptive word. It describes all of the data held in public and quasi-public digital networks. Second, globally networked computer processing power is ever increasing. The speed of the off and on commands that determine what a digital machine can do is reaching its optimum. It hasn't quite yet reached its optimum. There's quantum work. However, this is being increased, the speed is being increased by bringing together multiple machines in networks. So generative AI works incredibly quickly. It can find and combine vast numbers of most likely outcomes more quickly than flicking a switch. Let's ask generative AI to write a tough essay or answer a tough exam question. We type in the question. Like the search engine, generative AI searches for the most likely existing matches. Rather than presenting these matches, it uses most likely as a rule to determine similarities between patterns of the smallest units of any digital system, its patterns of zeros and ones. It approximates these patterns to generate new combinations of data, and voila. The new combination is produced according to the rule. You have your PhD thesis, your piece of music, the sound of somebody's voice. Generative AI identifies most likely patterns in vast acres of existing data. However, The new combinations that it produces according to most likely rules, the answer to the exam question or the new music, are not only most likely. Instead, when they're generated as new combinations, in fact what they are is typical. The new combinations of data created by generative AI, the answer to the exam question or the new music, only have characteristics that are shared with others of their type. Identifying these characteristics is the same as identifying most likely, except the combinations are identified in the new data, the new combination, not within the existing data. The new combinations of data resemble exam answers, other images, people's voices saying new things, new music, and so on and so forth. They resemble them. Sharing enough characteristics to be identifiable with others of their type is the single thing that characterizes them all. The most likely function applied to source data also identified shared characteristics in the searches. But these were simply patterns of ones and zeros. These patterns were the template for what becomes the pattern in the new combination of data made by generative AI. Being typical is the big drawback of content produced by generative AI. The drawback lies in the fact that the world of existing data, although vast, is limited. It is not infinite. There are types of data and patterns that cannot be found there because they don't exist. In essence, the pool in which generative AI fishes for patterns to approximate is more akin to a bucket than an ocean. Its limits are easily seen. This means that generative AI only produces combinations of patterns that already exist. Because of this, generative AI differs absolutely from the human imagination. This is easy to test. Let's ask generative AI another question to produce a digital depiction, an image of a university professor. It almost always produces a depiction of a white man of middle age. The command, university professor, is not in the world gendered or racially demarcated or demarcated by age because the rank of university professor is not gendered or racially demarcated or demarcated by age in the world. But generative AI only makes new combinations from most likely patterns in the finite data source. In this example, generative AI reveals that the most likely patterns in the digital source for the command, university professor, produce depictions of older white men. In the digital world, generative AI has shown us that university professors are typically older white men. We must be careful to understand that generative AI is not suggesting that university professors reproduce in themselves the image of older white men in the world. In fact, generative AI cannot suggest anything at all. It hasn't got that power. This is my point. Typification is always retrospective. It only confirms and reproduces the status quo. It cannot contradict it. That is why it isn't much use for compiling shopping lists. If what you want to get is a perfect tin of beans, or, more appropriately, if what you want to get is a tin of beans that only you can imagine. Thank you.